Okay, good evening. Let's see if this actually works. So, first of all, I'm not even sure if you can hear me, because I did change some filters in this thing. Like, I enabled... Whoa, you probably should be able to hear me. I enabled... what's it called? The noise filter, to make the microphone a little louder. Otherwise, it's really picking up a lot of noise. So you should be able to hear me a little better, because I know there were complaints that it's too quiet. Please let me know if it's better now, if it's less quiet, more loud, I guess. Is this camera like... Yeah, whatever. Okay, so it seems by looking at the chat that you can actually hear me, which is perfect. Okay, today's moderator is going to be KrzaQ. You can see his nickname here. And if you have any questions related to the live stream or not related to the live stream, then just ask KrzaQ and he will magically let me know that there is a question. Yes, bad news, there is no mission today, because I actually spent the last couple of evenings coding jQuery animations, which is a lot of fun, and actually reworking also the backend of my the script which I use for the live stream, because I had 3 separate backends running, and I decided to like put them all together, you know, to handle donation notifications, to handle questions, to handle like what music is playing in the foobar and so on. This actually had like an HTTP API like backend, so now everything is in one backend, so I'm a little more happy about how it works, and this also allowed me to do a new fancy animation when a donation pops up, but I still don't support animations for PayPal donations. Sorry about that, I will try to fix it. Anyway, great news. Actually, I got 9,000 subscribers on YouTube on this channel, which I'm super happy about, so thank you. It does seem that you folks like my vlogs, like video logs, which I'm publishing every now and then. They are getting a really positive response for basically being super short and not like 5 hours live stream style, which I guess I am doing a lot. So yeah. Okay, I do see that there is a donation, and I don't see it being shown, so this is quite funny. It turns out that my script isn't working. No, but let's give it a few seconds. Thank you, Pavel, for donation already, and I will try to see, and thank you for actually doing a donation. Then I can test it. Why isn't it working? No, it is. Perfect. So here we go. If the place actually changes, then there is some sliding animation added and so on. So I wonder why the lag. I think there was like about 10-second lag. I need to check. Oh, I know, because I actually also merged the... Yeah, there will be about 10-second lag now, I guess. Sweet, so thank you for testing. Now, today's topic is going to be XSS, like return to the basics. This is the most basic web client attack you can think of, and they are pretty popular on recent CTFs, though the XSSs on recent CTFs are more about CSP, and like a few streams ago I did show how to attack a CSP based XSS, but there will be no CSP today, but I will mention it. Yeah, we'll just do old plain XSSs, so this stream is more for the people who are just beginning. If you like are super senior in web, both I guess development really and web security, you'll learn nothing today. Like, go do something else, seriously, you will waste your time. If you're new to web security, then welcome, and I should have quite a lot of fun content for you today. Yeah, so before we get going, there are 2 more things to mention. First, I will do the questions in a second, and second, there will be a live stream. Oh, I did last week. I was in Germany, in Ingolstadt, which is actually a really lovely town. And I did a lecture there on the Hochschule, on the university, on zip file format. And there is a bootleg recording available already on YouTube if you look for it. I've linked to it in the comments on my blog, by the way, and the slides and so on are available, but I will be redoing the talk on the live stream on the 9th of May, which means in 2 weeks. So in 2 weeks I will be redoing my zip talk. It was quite fun. I think it was quite fun. I did get positive feedback, so it should be fun. Yeah, because it's the difference if I like go home from work, throw my backpack and start live streaming versus if I actually have a few days to prepare demos, to prepare slides and so on. Sweet. Let's do questions and then let's do XSSs. So let's start with questions. You should be able to see the questions there unless I broke the backend. No, it actually works. Okay. I've heard on the internet that on the latest preview builds of Windows 10 there are strange mouse cursor bugs. Even mouse cursor disappears completely. Can you suppose what may be the case? It's a good question. I don't know. It might be anything. So it might be either a bug related. Well, it's probably a bug around Win32k, right? Because that's Win32k is the kernel module responsible for drawing the windows, drawing the cursor, and basically all the graphical mode. So the bug should be somewhere there. Probably like some miscommunication with GPU drivers, because I think nowadays all the mouse cursors are being rendered by the GPU, but that's not done programmatically anymore. As in, well, it's done in the firmware or whatnot. But it's not like a command for the CPU to draw the mouse cursor. There is more like pass the position to the GPU, and the GPU will just render whatever cursor it's supposed to render. I think, a keyword think, I'm not sure about that. So yeah, something went wrong on that line probably. But again, it's supposing. We should ask a Microsoft engineer who is responsible for that, because they might actually have a better idea than I do. Did you read the book you got some time ago, Serious Cryptography? Any thoughts recommended for beginners? I didn't read it yet, in all honesty. I did read recently mostly cryptography papers on the zip encryption, how to speed it up, and what's the deal with CRC32 and how many fan attacks are there, but I didn't get to that book. Yeah, I might get to it someday, but I mean, looking at the name of the author, I would recommend it. I'm not sure for the beginners, but probably as well. I mean, yeah, the guy is like a really amazing cryptographer, so just for the name I would get it. Donors versus donators. This is, Chris, an interesting thing. I actually thought about putting donors and not donators everywhere. But it turns out that donators is actually also used on the internet. It's in some dictionaries, not in all of them. So in the end, I decided to leave it to basically distinguish between, I don't know, like a, hard donor in medical world versus somebody who's donating cash. Yeah, I might basically go back on that decision and actually go change everyone to donors instead. So yeah. But I am aware that donators is not a proper English word, but I might still leave it. Do you think there is much legacy code in big and old software like Windows? Yeah, basically yes. I think up until Windows 10 or Windows 8, there was at least one widget in like font window in Windows somewhere, which was created for like Windows 3 or something like that, and that code still stayed. There are a lot of legacy code around fonts, and basically there were several people, including Mateusz Jurczyk from Project Zero, who started looking at that and said, well, this is legacy code, there should be bugs, and bugs there were. So yeah, it's one of the, I think one of the things which Mateusz likes to repeat, that he likes to find a area of old code in Windows and style to review it, because current modern standards in writing code are way better than what was in the past. So, and large software like Windows, or I don't know, parts of Linux probably as well, X server and so on, these do tend to have areas of old legacy code. Okay, cool. No more questions. Perfect. So let's go to today's topic. Here we go. Oh, actually, even the correct monitor showed up. Oh, there's one more question. Okay. Is Wi-Fi a risk for our health? And this is an excellent question. I don't know. I hope not. Especially that my access point has 6 largish antennas to cover all my apartment, so I hope not. But there is, in all honesty, there is some. I know there is research going on in that area, and also related to our cell phones, which I think recently there was some research published, but it's actually worse for our health than it was expected. So yeah, let's see what happens in the next few years. Isn't most of Windows code very old? I don't have access to. It's a good question, Derbe Supervisor. I don't have access to Windows source code, so I cannot judge. I know a lot of code is legacy, but I'm not sure how much of it. Is it most? Is it not most? I don't know. I just don't know. But it's actually a fair guess that most of it is old. It is a fair guess. I wouldn't say no, it's totally not that case. I won't say that. Sweet. So XSS, what's an XSS? Cross-site scripting. Oh, by the way, if you have more questions, keep asking them. If the question is related to the topic of the current stream, I will answer it immediately. Otherwise, I will answer it at the end of a stream or when I run out of things to talk about, I guess. Cool. So, okay. XSS is basically when a website takes some input and that input is being reflected back to the client, to the browser. I will be using browser, client, or user probably as a synonym today. And that piece of input actually contains usually JavaScript code, which gets executed in the context of a browser and shouldn't be executed in the context of a browser. There are cases where that's actually desirable, that the code is executed. I will also probably mention that today. But yeah, and I guess the question here is, why do we have that problem in the first place? And that problem we have, let's maybe create some code. Yeah, the problem we have, because when we start writing, I don't know, like HTML, okay, I will use the word code, but HTML isn't really a programming language, of course. We cannot really distinguish between data and code, which a code in JavaScript would basically look like this, right? The ASDF would be interpreted as code. As you can see, if you would look at it from a hex editor, there is absolutely no way to distinguish whether this ASDF is code or whether it's just data, apart from looking in what context it's specified. Like this is the script tag versus this is code. And there are basically two ways to approach creating such things. Usually you want to have data in one layer and code in another layer and never mix them. If you start mixing them, like for example, do some magical escape sequences in data where after the magical escape sequence, suddenly the stream of bits starts to be interpreted as code, and this script here is a magical sequence after which suddenly the data becomes code, which gets executed, right? Yeah, then you will run into problems that if you get some input from the user and then just put it right here inside the data, then if the input contains that magical sequence that switches the mode to the operational mode to code instead of data, then you will have a problem. And this is what I just gave you is a general description. It's XSS is one example of it. Actually, terminal control codes are another example of it, and in the past there were some bugs related to that. Not as bad as XSS, but yeah. Just to give you an example, what's the terminal escape code in case you probably all know, right? But yeah, just in case. It's basically when you echo something on the terminal, this is actually echo sends whatever I typed to the first file descriptor, which is standard output, of course, right? And that is connected to the terminal process, the console emulator, which is basically the application which handles drawing the window and drawing that font here. And it takes the input and starts processing it and looks for escape sequences. In this case, the escape sequence is actually uses the escape character. The escape character is x1b. And then there's some magical thing which you can put here. For example, let's do 35M and something else. And this magical sequence was never outputted, as you can see, but the color changed, right? Because this is a magical sequence which you put in data and it gets stripped from data, but something starts. And when I mentioned that there were bugs in the past, like the bug would, for example, allow you to put a string in the standard input, and then when the user would press enter, that string would get executed in bash. And yeah, this is something you don't really want to do. For example, the way you achieved that is that there was an escape sequence which allowed you to set the name of the terminal, and then there was another escape sequence which allowed you to query for what is the name of the terminal, and that query would actually make the terminal output the name of it to standard input, assuming that the application which requested the name would read it from the standard input. But if it was like, I don't know, like an FTP banner, you connected to an FTP and it just showed you the banner and exited, then you'd get the command, the name of the window actually to bash, and it might have been like rm-rf something, right? Which you totally don't want to press enter then. So yeah, and XSS is basically like, it's the similar kind of a problem, just in web, right? Cool. So there are, I guess, well, several types of XSSs. Usually we name three types of XSSs, but there are several categorizations of XSSs. First is called reflected. So let's do a reflected XSS, and I'm going to do some magic here, which I will explain later on. Header XSS, what is it called? Protection 0. I will explain what's that in a, well, not in a second, but later on, because there is some fun stuff we can do with it. And then we have something, and here we actually reflect an argument from the user. So in PHP you just write that, and let's assume that what we reflect will be given in the x variable, in the query, in the URL. Yeah, and that's it. So now let's run a server. You can actually, do I have a console here? No, I don't. Oh, by the way, I can show you KrzaQ's blog, which I guess still has the post from beginning of April, which you should read. Proper digit separator. It's actually a fun post. As you know, for the 1st of April, it's still really fun. I will be using this this browser today, though I do need to run a terminal emulator. Here we go. Well, a console, whatever. PHP-S actually starts a web server, a PHP web server in a given directory. It's not to be used in production, but it actually serves the purpose for, well, what I'm like demonstration purposes, basically. So now I can connect to it. That's not it. This is it. And the name of it is asdf.php, because I can name stuff really well. And now if I type x and something, that something will not be reflected because of reasons. I don't know why isn't it reflected. Because I forgot echo here, because I actually need to output it. Okay, here we go. Yeah, so it got reflected, right? Whatever I type here gets reflected. And if I do the magic escape, which is actually a script tag, then I can execute script, right? And usually what you see people do is alert 1. This is basically like an equivalent of getting EIP to be for one in low-level exploiting, as in proof that you got code execution. Obviously, a better way to do it is actually do document location or domain. Yeah, because this displays the domain, and sometimes you get code execution on a different domain, and that just isn't a bug, but I will again get back to that later. So yeah, if you type something in a URL bar or in a post and it gets reflected and it actually executes your code, this is a reflected XSS. This is the first type of XSS. The second type is actually so-called a stored XSS. It's the case where whatever you send to the website gets actually stored in some file and then, or database or whatever, right? And then when somebody else, or maybe you, enters the website, it gets, digged out from that database and displayed, including the code execution, which happens. That's a stored XSS because it gets stored in some database for later use. Because in reflected XSS, somebody actually would have to enter this URL to get attacked. In case of stored, but the attack is already in the database, and whoever later on enters a given URL that doesn't include the attack itself will still be shown that attack from the database. So that's a stored XSS. Okay, so I see there are some questions related. Well, see, KrzaQ told me. Do you know what WebAssembly, and if you have, if so, have you tried it? I know what's WebAssembly. I didn't try it yet. That being said, yeah, we should chat about WebAssembly at some point, because I was waiting for it to be available in browsers, and now it is. So yeah, we should chat about it at some point, but not today because I didn't try yet. Maybe XSS with WebAssembly, maybe later. But yes. Can the success of XSS attack depend on the web browser family or version? Can it be patched by a browser manufacturer? That's actually a really good question, and we will get to that. The answer is yes, it can depend on the browser and version due to reasons. And I will get to that later too. And can it be patched by a browser manufacturer? No. Yes and no, but basically no. And I will get to that as well. Ginveil programming in PHP that cannot be. I actually programmed quite a lot in PHP. Like the first website I did in PHP, that was 2003. That was 15 years ago, or even 2002. A lot of websites do not escape image on error alert. Oh, so that's actually what the IFAM 5 says is another way to do. Usually websites, sometimes websites look for this magical string, and therefore I personally don't really use this. I use what was suggested. Let me create a notes. Yeah, so this is like one way to test. The way I prefer is actually to do emg src equals something. This is an image which doesn't exist. This will return an error. The image will not be loaded, and this is exactly what we want. On error equals end the script here, and yeah, that's it. This is a little better because some what are they called, like web application firewalls / intrusion prevention systems try to block on script, but this usually works fine. So we can double check that it works fine. Okay, yeah, and it works fine. Okay, so I did mention that there are 3 types of XSSs, and the last XSS type is actually called the DOM XSS, or I don't know, client-side XSS, whatever. It doesn't really have to have a server. So in this case, we have a server, right? And the server echoes back whatever we pass it. But let's assume we don't have a server, so I'm going to comment this out. This is not going to be executed. And instead we have some JavaScript code which actually grabs something and reflects it, something that is passed by the user. For example, let's hide the comment. Okay, let's do this. Script, okay, and then we fetch let x be equal to document location hash. Oh, just location hash I think will work too. And location hash is actually what you type after the hash, right? ASDF. ASDF, this is not sent to the server. Whatever after the hash is typed is not sent to the server. This is well, an anchor on the website, but actually modern JavaScript uses this to pass on parameters. And yeah, so we get it. Let's just console log x. Let's just make sure I didn't do a typo here. So, okay, I pressed F12 to display this console. And let's do it again. Yeah, it actually returns the whatever's after the hash. So if we would do something like, let's say PID equals ASDF, because, you know, my naming is usually really good. Document get element by ID ASDF, and this is the P element, and P dot, how do you change the text, like value, I think, is going to be whatever we put in the hash. This isn't working. If you type debugger here, by the way, Chrome will stop the debugger here so we can do some inspection with like some JavaScript programming tips. And yeah, we paused in the debugger. And the console here, we can actually check, well, inspect the it's not value. Is it text? Oh, I know, it's inner text. Yeah, I'm so stupid. Okay, not a function. Okay. Can you see it, by the way? Yes, you can see it. Well, it's a little small. Yeah, it's a field. It's not a function. And if I do inner text, that will actually not be an XSS. But if we want to do an XSS, we do inner HTML. Perfect. And X should be, yeah, that should be fine. So let's try again. And yeah, and it works. We got it displayed here. Now, if we would actually have again the XSS here. So I'm going to copy it, refresh, and nothing happened because it's escaped. Let's, I'm going to switch to this one because this doesn't have any spaces, so it should be fine. Yeah, we'd have to probably de-escape it. That's a normal thing, actually, to de-escape it. What was the name of that function? Versus function in JavaScript to de-escape it. JavaScript URL decode, I think. URL decode component, yeah, that's fine. Okay, here we go. And yeah, I'm not really stretching it much by including this function. This function is commonly used to decode the parameters because you don't really want the URL encoding. This is URL encoding, by the way. This is a percentage sign followed by 2 digits, which are a hexadecimal value of a character. 20 is a space, obviously. So yeah, saved, refresh, and did it work? It did not work because it didn't decode. I'm messing something up, I feel. Let me double check what's the name. Does this work? To be. Yeah, it seems to decode, so why didn't it decode here? That's a copy-paste error. My apologies. Okay, here we go. Yeah, this works. The script was not executed for some reason, but it should be here. Oh, I will not see it here. If I open the console again, if I go to elements, I should see it here. And yeah, there's a script here. It didn't execute for a reason. I'm going to switch to this payload, and here we go. It gets executed. Okay, yeah, the 515. You want to use the code for encoding the string. Yeah, that's true. Thank you. Okay. So this is a so-called DOM XSS, which basically it's all done on the client side. There is some client code which gets something from the user and then reflects it after decoding without using properly, like inner text, for example. If I would use inner text here, inner text is actually escaped. And this is escaped. This doesn't execute. It's fine. It's okay. yeah, so that would be fine, but if there would be inner HTML is something you probably want to look for when reading the source code of a website you're auditing for DOM XSSs. Cool. Now, here's the question. What are XSSs used for? Sorry, what are XSSs used for? Because, well, I can output the path and the domain, or I can display a message box with one. That doesn't really sound too terrible, right? Obviously, you know it doesn't end there. It allows you to do whatever JavaScript is allowed to do in the current context of the current website. And that usually means, like, think of think of some random website where you can actually log into and you can do some stuff. If you are logged in, then that means you have a session established with the server proving that you are you, right? You had to log in, so you probably have a cookie set, and the cookie has the session ID, and the session ID can be swiped by the attacker. Because cookies usually, but not always, are accessible from JavaScript. So that's one example. Then another example, even if you cannot swipe the cookie for a reason, then you still can interact with the website, which means you can grab the whole website, you can click any buttons, send any forms, get any XSRF tokens, get anything which is on the website and navigate on the website through the website, steal like a CAPTCHA image, enter the CAPTCHA image, and so on. So yeah, you can basically behave as the user if you have an XSS. So this is a pretty powerful attack. And yeah, usually one of the reasons, actually, if you want to change a password on a website, you usually have to enter your current password. And that's a good thing, because if that protection wouldn't be there, that you wouldn't have to enter your password, the XSS could actually, an XSS attack could actually, well, just change your password, right? Yeah. That being said, in some cases, the XSS can just spoof the login field and get the password anyway, but that gets complicated really fast. So yeah. Okay. What do we do next? I guess I wanted to first show you some more complex things you can do with an XSS. So, well, this isn't really complex, right? So I'm going to first show you how to exfiltrate. Let's start with a cookie, because that's simple. Cookie, then a website, and then maybe an image. Like how do we exfiltrate an image, for example, a CAPTCHA image, right? Yeah, and then we'll get to protections. I'm not going to talk about escaping. I'm going to talk about the XSS protection field, and maybe about CSP, and yeah, and then we'll see. So let's start with cookies. I'm going to comment this out, and I'm going to comment this back in, but actually I'm going to add some more code which actually starts a session. So to start a session in PHP, you write session start, session start. Okay, and that's it. That actually populates already the cookie, and that's fine. So if we reload the page, and let's do just that, I'm going to switch to the network tab. Okay, here we go. This is downloaded by some plugin. I don't know which plugin downloads it, but I think I'm going to check later, because that's quite interesting. Yeah, and we can see that the cookie is already set. Now, the cookie doesn't have any magical flags. There are a couple of flags which you might be interested in. First of all is secure. Secure means that the cookie is accessible only from HTTPS, because usually if you set a cookie even on HTTPS, then it's still available on HTTP if you browse the website through HTTP. And the other is HTTP only, which basically makes a given cookie not available to JavaScript directly. It still means that there are ways to steal it, but things get really complicated really fast. So yeah. And it's possible to steal a cookie like this only if it's basically reflected by the server. So if a server for some reason reflects a cookie, for example, somebody leaves a PHP info .php file lying around the server. But side, I think, is pretty happy to actually reflect the cookies. So, yeah, then you can steal it. Otherwise, if the server isn't kind enough to reflect it or reflect the HTTP packet you sent to it, I think there's like something called trace, like an HTTP method called trace. Instead of get, you would send the trace, and some web servers would actually just echo back the packet you sent, and the packet would contain the cookie. And given that it was a website, you could interact with JavaScript with it and steal the cookie. But I think modern web servers no longer do it, like have this disabled by default. Cool, so let's swipe the cookie. To swipe the cookie, we basically need our HTTP server waiting for the data. And I'm going to use the best HTTP server which is there, which is Netcat. You probably know that Netcat isn't really an HTTP server, it's actually a program which just opens a socket. So I'm going to create an open socket on port 9999. Perfect, and it's listening. That's fine. Now the exploit which steals a cookie is, well, rather simple. It's going to be, we're not going to alert it. What we need to do is we need to do two things. First, we need to swipe the cookie, and to do that, and again, this console is really, really useful to experiment with JavaScript. Again, F12 on your Chrome browser, or actually any other browser, all modern browsers implement this. We want to do how to get the cookie. Document.cookie. And it will just happily give us all the cookies which are associated with a given website, which are accessible by JavaScript. So that's that. So we need to first get it. Document.cookie. And then we need to send it somewhere. My favorite way, wherever, you could go as far as actually create an XHR request, which is basically an asynchronous request to fetch a cookie. Another way is you could, for example, create an image tag where the URL that is being fetched by the image actually contains the cookie and it leaks it to a different server. But I just prefer to redirect the browser, and to redirect the browser you do location.href equals and the URL. So yeah, let's I don't know, do this here just to show you. Again, Veil called doing PL in case my blog actually works. And yeah, it's waiting because it's already loading. So yeah, I seriously need to make that websites faster. Yeah, okay, and loaded. So yeah, what you do is basically location.href equals the exfiltration address, which I guess we can shorten up to this because we are not operating on HTTPS. Then we can put the port and the document cookie as in we append to it. And that's it. That's the whole script for stealing a cookie, which doesn't contain any magic. Here is our web server. Let me maybe put it here. Yeah, here's the website. Okay, X equals this, bam. Unexpected identifier, I did mess something up. Script location, blah, blah, blah. What did sorry, what's wrong with you? Oh, sorry, I'm just being stupid. This is actually URL encoding for a space. So we need to do URL encoding here, and the plus is %2b. Yeah, and here we go. As you can see, we got the request, and the request, well, we need to scroll it a little up. Yeah, the request is to get / and thank you. We have the cookie now, and as an attacker, we could set this cookie in our browser and impersonate the user, unless the session is actually tied to, I don't know, an IP address, the user agent, some other fingerprinting of the user, or there are more cookies which are actually identify the session. So yeah, sometimes stealing the cookie is okay. On CTFs, this is usually enough. but on real websites, usually it's not enough to just get the session cookie, but it's a classical attack. So yeah. There's a question, can you talk a little bit on executing XSS on frameworks like Angular or React.js? What are some things to look for when testing this kind of applications? In all honesty, I cannot really talk about it because I don't have too much experience with it. As in, I have zero experience with React.js, and I played with Angular when there was version 1.0, and that was ages ago. So yeah, it's beyond my expertise, in all honesty. That being said, it reminded me of one thing. There is something called HTML5 cheat sheet, and it's a website. Security cheat sheet. Yeah, HTML5sec. I'm going to give you links. This is a super useful website. Basically, what I do if I do like a review, I do Control-A to select everything, Control-C, and then paste the whole page into a text field, which on the website I'm reviewing, because this website contains basically all the weird ways you can achieve code execution using random tags, like for example, form action, and your JavaScript goes here, and it works in these versions of browsers. This is basically related to the question that was asked before. Or you can use like video on alert, and it works on these versions of browsers. So if you encounter a website where like an intrusion prevention system or a web application firewall or like some part of the website is blacklisting specific keywords, like for example script or on error, go to this website. There are like, I don't know, a few hundred probably of ideas on how can you execute JavaScript on different browsers without using some keywords. And it really depends on the browser version, of course, but there are some which work on like latest Chrome, for example, right? And so there are some really cool tricks here. So yeah, going back to the topic of exfiltrating stuff. How do you exfiltrate the website? This is something also really useful on a CTF. Wait. Yeah. Okay. On CTFs, yeah, and it's actually rather easy if I remember. I don't remember the exact command, but we're going to find it. What you want to do, you also want to have a web server running. Again, netcat is enough. Netcat is usually enough for exfiltrating data. Then what you need is grab the document and convert it, well, grab the HTML of the document and convert it to base64 or something like that. So, well, document dot, I think inner HTML should work, or HTML, we will try it out now. There was a nice way to do it. We just have to figure something out, I guess, on the fly. You can obviously go to Stack Overflow. I usually do that on a CTF, in all honesty. Get HTML of website in JavaScript. And probably I can JavaScript read, blah, blah, blah. Now this is for cross-origin. This is not what I'm... Oh, yeah, maybe this. Oh, this is again cross-origin. I don't want cross-origin. Yeah, it's probably... Oh, Mr. 7F says I'm missing body. Yeah, I knew it was something with inner HTML. Thank you. And yeah, it does return, but only from body. So as you can see, if I would have something here, it would probably not be returned. Let's try it. Head, and I have like some, I don't know, meta char set UTF-8. Okay, I'm going to reload the page, do it again, and yeah, it doesn't give me the whole website, only the body part. I'm pretty sure there was a way to get the whole one as well. Let's try HTML. Then document dot get element by tag name. Yeah, and by tag name we need HTML, and then inner HTML. No? Can we convert it to string? We probably cannot. HTML collection. Oh, okay. 0 and now inner HTML. Yeah, and here we go. This is a better way to get it because we also get this part. Now, if there would be something before HTML and after HTML, we wouldn't get it either. But yeah, in such cases, we just need to figure out how to do it. Oh, there's an even better way. Alexandra says that you can use this way. Document.children0 inner HTML, sorry, inner text HTML. This gives us everything. Does it give us really everything? Let's see if it would give ASDF, which is actually before HTML. And oh, it would actually start body. Yeah, that's actually fine. The web browser tried to actually, well, correct the website a little, correct the DOM structure. So this is fine. I like the way. Thank you, Alexandra, for actually suggesting it. So we have a couple of ways. I guess I'm going to copy them. I will share the notes with you folks later on my GitHub as usual. And let's also use this. And let's grab the oh, it was actually body. Yeah. And now what you do, you basically do this, because why not? Oh, we need to base64 encode it first. So there's a way to base64 encode it in JavaScript, like actually a function to do it. Base64.js. Perfect. And MDN, by the way, Mozilla Developer Network, is something this is a great resource for JavaScript. Like, probably second or sometimes even better than the official specification. That's my take on it. So yeah, I'm going to include it in the notes as well. Yeah, A to B or B to A. B is base64 and A is ASCII string, if I remember correctly. So A to B. Okay, and let's use this one. And let's copy it and put it here. Now, you might be wondering, so, or actually, like, what if the website is really super long? Then isn't there a restriction for the limit of the size of the URL? And I think there is, but the limit is usually enforced on the on the server side, and browsers are usually quite relaxed about it. At least I didn't have a problem yet, but I didn't even, well, never actually went more for like, I didn't go for websites which are 1 megabyte, so no idea. Okay, and let's try to leak it. So here we go. X equals this, and it says unexpected because I didn't change the plus again to B because URL encoding. Failed because no A to B on Windows. Not A to B. Oh, B2A, seriously? Seriously? I don't know. So what I told you about A being ASCII and B being base64, I was wrong. My apologies. I did not expect that. And yeah, here we go. We got the base64 string of a website. So we can run Python. Yes, I want to put. And we can decode it. Can you see what I'm typing? Yes, you can see. Decode base64 Burley. And we have a website. So yeah, this is how you leak it. Now, the last thing which I wanted to show you, which sometimes is useful, is leaking an image, like a CAPTCHA. And this is a little bit tricky because sometimes you need to leak an image and then still have the website running and somehow tell your script running on the website, okay, the text on that image, that was actually ASDF, and your script would follow up with filling a form and sending it out. So yeah, I'm not going to go that deep, but sometimes you need to do it on a CTF, and then things go a little more complicated, because in your JavaScript you actually need to start doing asynchronous. In your XSS payload you need to do asynchronous callbacks. That being said, what I would recommend is actually do in your payload, do script and then import jQuery, because jQuery is super simple to use. And yes, in XSSs you can actually import jQuery and other stuff like that, usually. So don't be shy about importing jQuery in your XSS payload, unless there is a reason not to do it, of course. Going back, let's find a CAPTCHA. I'm going to draw a CAPTCHA then in Paint. Perfect. So ASDF, it can be anything. Now a human cannot read it, but whatever. Okay, and it's saved. So now on the website, we can actually include it somewhere here, emgsfc CAPTCHA, the PNG, not PHP. And let's open our website again, going back, not using this, not found because it's called asdf.php. Here we go, and this is our CAPTCHA. Yeah. So it's correctly displayed, and now let's try to find a way to swipe it in JavaScript. Now the way you do it is you actually need to grab the pixel data somehow, right? Well, okay, there are two ways to do it. One way is to actually do an asynchronous call to fetch the file, like captcha.png, from the server, and then you get, well, the data of the file. You get the PNG file bytes, and you can exfiltrate them using the exact same method which I showed before. But usually you don't really want to fetch the image again, fetch the CAPTCHA generator, because actually fetching a file, if the file is actually like a PHP script or a like, you know, a resource with a handler on the server side, that's executing a function, and you don't want to execute the CAPTCHA generate function because that would regenerate the CAPTCHA, and you don't want to regenerate the CAPTCHA. You want to grab the CAPTCHA which is there. So unless, well, sometimes it might make sense to regenerate it, but let's assume that's not the case. Yeah, so yeah, what you do is you create a canvas, then on that canvas actually draw the image, because you can do that, and yeah, and from the canvas you can get the pixels. So in JavaScript, what we need to do is we need to first create a canvas element. So I totally don't remember how to create it. Create canvas element dynamically. This is the way you do XSSs. You actually Google for them. Okay, so we get the canvas, which is, let's call it C. Yeah, create element. Yeah, I should have remembered this one. And now we have C, which is actually the canvas. And there is some stuff here like the width and height. We don't care too much. What we want to do now is we want to get the image and draw the image. So we are going to use again the document get tag by name. I believe it was called. I was actually here. And we are looking for EMG, and there's only one EMG, so I'm going to, because this returns an array of all images which are all EMG tags which are on the website, and we actually just want to grab the first one. Okay, so let's do this, and now I is actually pointing to this, but I should have a method which is like get image from it. I guess we will get to it later. Now what we need to find is JavaScript canvas render img tag. Yeah. Draw image is probably what I'm looking for. And yeah, we need this get context totally. So var ctx. Canvas is just a tag, but we need a way to draw on it, and that's called the context. So yeah, get context, and we need the 2D context. There's also the 3D context, which is, you know, OpenGL. Well, WebGL in all honesty. Draw image. There is no magic to it, it seems. Draw image, I, and the position, which is 0, 0. Let's try to execute this here and see what happens. Okay, did it actually execute, and did it actually give us... Oh, we didn't attach the canvas yet to the DOM, therefore we cannot see it, but that's fine. We can now get data, get image data. This is the function which we want. Okay, and it's a function. We need to pass the 4 arguments, which are basically the width and height of image, like where to start getting the image and where to get it to, which pixels are you interested in. And I'm actually going to give it just the size of this image because I know what is the size of the captcha. I could get it programmatically, but I don't really care. So 530 and 202. Okay, and what it returns an image data object, and it has actually an array. And the array contains the RGBA, like red, green, blue, alpha information for each pixel. So yeah, let me copy this. And this is, yeah, the EMG data. Then we get the data from it, which is, sorry, let me do EMG equals and EMG data. Yeah, this is basically, well, this is, you know, the white color, right? So this is 1 pixel, this is the second pixel, and so on. And what we need to do is we need to basically base64 encode it and send it somewhere. But yeah, I guess we need to first change it into what's it called? Character codes? How to do it in a fast way, I'm wondering. I'm going to do it in a slow way because I can. Image data, it doesn't have to be fast. For each, and this calls a function which are defined, I defined, and I'm going to do this. K plus equals a separator, and then just like the value. And yes, this is it. Okay, so I'm going to copy this. So copy. Here we go. Now, this returns a string. This is a string, and the string looks basically what you saw before, right? So yeah, this is a string. I just concatenated all the values with using a comma, using this like for each element of this array, run this function, and this function appends to this string the value and the separator. Somebody says that I could do array join as well. I'm wondering if it would actually work. Let's try it. And ABC is that somebody. So array. Oh, that's join. Let's see if it works. Oh, it works. I didn't want to do it because I thought it, like, yeah, JavaScript would complain that, oh, you're trying to concatenate integers. Are you crazy? But that's JavaScript. JavaScript is crazy. So I'm not going to use this. I'm going to use this, what I've just learned from ABC. Thank you very much. Okay. Here we go. Now I have this K, and now this K can actually be sent to the website, right? So let's just reuse what I've done here. Let's see, because this will be over 1 megabyte, right? What's the length of the string? K length. That's 1.2 megabyte. So that's quite a lot. I'm quite curious if the browser will be happy to actually include this in the URL, or if we will have to use, for example, the post data to exfiltrate it. Let's see how it goes. So this is fine. Let's just do K here. And this is a good payload. So now I'm going to actually do this. Now, is there any plus sign here? Yeah, there's at least one plus sign, which I need to get rid of. And it's here to be. In all honesty, for more complicated XSSs, just write a script which generates it from you. So you code it like this, and the script actually does all the, you know, removing the lines, changing the plus sign into the percentage to be, and so on, because it's doing it by hand doesn't make too much sense. I do have to restart this one, like the server again, and I do have to do x equals. Did I put equals here? No, I didn't. Okay, let's see what happens. I forgot script. That's embarrassing. Script. It says, failed to execute, the provided value is not of type. Let's see what I did wrong. So wait. Yeah, draw image, right? The draw image is the problem. What type is it of then? I is undefined. Why is it undefined? Okay, so no, wait. I wanted to say that the problem here might be that the image is not yet loaded, therefore it cannot find the tag. That's actually true, because the image is loaded after the script is already executed. So I'm going to put the image here. What you would normally do is you would like add set timeout and wait for half a second. Actually, let's do it, because why not? So I'm going to add set timeout, which is basically execute whatever I'm going to give you after some time. This is the function I want you to execute, and after like half a second, that's fine. Script, okay, and script. Perfect. Now, let's put it here, and it failed A to B. Oh, did I again mix it up? It's B2A, right? Yeah, it's B2A. B2A. Okay. Okay, and we got it. Well, we got something. I'm not. Oh, I think we got everything, because there's this thing here. So now let's actually play with grabbing this data and actually displaying the captcha. So I'm going to save it into packet.1. This is usually the way I name it, which is probably better than my usual naming. And I'm just going to restart the XSS. Oh, once again. If you're wondering, yeah, like, don't ask. Yeah, let's go here again. Oh, wait, that isn't it. Send me the data. Come on, send me the data. Oh, because it sends it to... No, that's fine. It puts it in the file. So it actually worked. I was waiting for the terminal to show up. Control-C to kill it. And there is actually a file now. If we do ls packet, there is a file which is 1.7 megabytes. I'm going to open it in Sublime. It looks beautiful. I'm going to remove this part, note this part, and I'm going to remove this part starting from here up to the end. Here we go, perfect. And I'm going to close this and I'm going to run Python. So Python, I'm going to read the file, it's called packet.1, read it, and then decode base 64. and then I'm going to save it in c.raw as a binary file. I'm going to write this data. Here we go. And yeah, this is decoded. So I basically opened the file, read it, decoded it, and then outside of it, I opened the file called c.raw for writing in binary style, and I told it to write whatever I decoded here. So we have the file. The file looks like this. So we still have to, well, change this into something readable. I guess I'm going to run Python again. I'm wondering how to do it in an insane way, and I think I found a way. I'm going to open the 0. I'm going to find... Oh, I think there was a... No. I thought there was a comma at the beginning. Why there is no comma at the beginning? Oh, because I'm using join now, so that's fine. I'm going to do this. dopen 0 read. I don't need to write this. Okay, and D has the data now, and now I can just do import JSON dot load from string loads. Let's see if this library decodes it, because actually the JSON specification says that you need to have an object as an exterior, but maybe it will work. Okay, no, it works. Yeah, it's fine. So it's good to know that Python's library doesn't really comply with JSON specification, but that's fine. Yeah, and now we need to convert it to a byte array, basically. Byte array k, and it's going to be r, and write r into a file. So d.raw, write binary.write r. Here we go. And perfect, a binary file was created. Here we go. So now we need to basically open it in something which can read raw files, and I'm going to use irfanview. That's why I named it, by the way, .raw, because irfanview opens raw files. I just have to put, well, the width and height here. It was, what was it? It was 530 and 202, right? And it's actually 32-bit. So 32-bit, boom, and ASD, and this is missing because I probably messed the resolution. It should be a little bigger, but yeah, whatever. This at least shows that something got exfiltrated, and I'm fine enough to leave. No, I know what was the problem. This is funny. The problem is that my website, sorry, not this website. Please go back to the website. Okay, here we go. No. Stay on my website. Don't redirect. Thank you. This website is actually zoomed in. And when something is zoomed in, the image is larger. And when grabbing the image, writing it to the canvas, actually grabbed the enlarged image, and therefore the full image was not copied. This is what happens when you start playing with canvas, I think, with an enlarged website. But that's fine. Something leaked, and it would normally, in normal cases, like leak actually the whole thing and not only the part of the captcha. So that's it. That's what I wanted to show you. Okay. Now, yes, now let's chat about protecting against XSS. So first of all, you need to understand that there are several contexts where the XSS can appear, right? So what I've been showing you today so far is basically this context is outside of tags, right? So we have, it basically appears between two tags, but so this is one way to do it. Well, one way to make a mistake. Another common way is like if you have an input, ID something, I don't know, and then value equals, and you echo whatever the user gave you. Let's go to the y. Yeah. Well, and here you can, like, the attacker, oh sorry, I totally forgot this thing. And the attacker could here just do y equals, sorry, this. This is, by the way, the usual thing you want to, when you're testing for XSS, this is usually what you want to do. And then, like, you know, script, blah, blah, blah. The usual thing. If you cannot use these characters, then try on error equals something, or try on hover, which is basically on mouse over, like mouse over. This works obviously only when you have a mouse interaction and somebody would just go through the mouse through the website and hover the mouse over this input. This would probably get executed. Yeah, so this is another idea. Then sometimes, rather rarely, but it still happens, you get into a quite funny context of like this. Var x equals, and then you have a string, and then happily something which something is echoed here. Yes, and script. Yeah. So this is another context. Now, sometimes you might also get into the context of like style, right? CSS. And I don't know, like body, background, color. Yeah. And there might be other contexts as well. So, well, the problem for the attacker, for the defender, for the creator of a website is basically to know when to use which escapings, right? Because here you would use the / escapings. Here you would use HTML entities. And here I have no idea what you would use. Just don't do it. So some frameworks have context, like templating systems, which have context aware escaping. So they basically know that, oh, if you're like putting echoing a variable in this context, like in style, it should use this kind of encoding. And if you're like in this, then you should use the JavaScript style encoding. And if you're in this context, then you should use HTML parameter entities basically. And here you should basically use everything. By that I mean HTML entities. So for the defender, it's super important to actually know what context you are escaping for, because if you start mixing contexts, it turns out that you are in a world of pain, because if you try to use JavaScript escaping here, it just doesn't give you anything. Like, you can still totally run the exploit. Just some tweaks here and there, and yeah. And probably the same here, though. If you escape quotes, it gets a little more problematic for the attacker. So yeah, that might be a little better. Oh, by the way, this should be well, no, because this is executed on server side. This is fine. By the way, in HTML, at least in Internet Explorer, you could actually do something like expression and then alert1. That was how you could execute code in Internet Explorer, but I'm not sure that's still the case. Let's go again to this beautiful HTML5 sec.org website. Let's see if they have expression. Oh, here, for example, they have one way to get it in the context of CSS. And please note that there are no triangle brackets here, right? So even if you would do HTML entity encoding in this context, that didn't really give you anything. But again, this is an old version of Internet Explorer, and well, currently nobody should use it anyway. So there's Edge if you want a modern browser on Windows, or Chrome, obviously, or Firefox Quantum. Anyway, so yeah, do content encoding when echoing back variables from an untrusted source. That should be your default. Always do that unless there is a good reason not to. And be aware that in different contexts you should use different things. Now, there was a question at the beginning of the stream about, so can maybe browsers actually patch XSSs? And well, to patch an XSS, you basically have to modify the website a little. And my general answer is no. That being said, some browsers employ something called the XSS protection, which is basically an antivirus-like approach, like signature scanning approach to, well, to this, right? To protecting against XSS, as in, if the browser would actually detect an XSS payload, and this is basically where funny things happen. I will go to that in a second. Like, if the browser detects this in the URL, and then it detects this on the website, it says, ooh, somebody is attacking. So I need to do something to prevent that attack. And that something actually is one of three things. The most boring one is basically reported to the website owner that, hey, an XSS attack was successful here. I think that's supported only in Chrome or Chromium, according to MDN, by the way. The default mode, I don't remember what's the default mode, but there are two more modes. One is called 1, which is enabled, and this is try to prevent the XSS. Make the website render, but try to prevent the XSS. And this actually introduced an attack vector, and I'm going to show it in a second. But the other thing is mode equals block, I think. Do double check it before using it. And this means that if the browser detects something which looks like an XSS attack, then just block it. Don't render the website, don't execute any code, don't show the website, just block it. And this is the most sane way to do it. So if you plan to use this in blocking mode. Now, yeah, let's go back to this mode. And I'm actually going to do a somewhat funny thing now. I'm going to actually create a new website. I do have a new website even created, so it's called ASDF. No, it's called test. Here we go. Okay, I have the XSS protection enabled, and now I have some different JavaScripts. And let's assume that here we have some code which goes like this. If x equals to 5, then send passwords to attacker. Just pretend that there's something like that, okay? But when you see what code is executed, it first executes this script, and therefore, well, x is set to 5, right? And then it executes this script, and this x, the same x, this is the global scope, this is fine, x is set to 8. So this is no longer valid, right? And then if we would check if it's 5, well, we know it's not 5 because it's 8, because we just reset it, right? And as an attacker, we might want to play with it a little. So let's enter this website. Test.php. And there is no input here. There is no XSS here. No XSS at all. And yeah, I'm going to, I guess, do... Oh, this is fine. Yeah. As you can see, the echo was set 8, right? Which means this actually got executed. So what I told you before is that the XSS protections works like this. If something which is in the URL address here gets discovered in the source code of the website here, then it will try to block it, as in it will remove it from the page. Therefore, we are going to put this in the address bar. There is no X parameter. This will not be echoed. This is not an XSS attack. But we are tricking the browser into thinking, oh, we are doing the XSS attack. And the browser will look at it and say, hey, this is a script tag. And yeah, it looks like JavaScript execution. Is there something like this in the code? And there is it in the code. So it thinks, there's a heuristic, right? It thinks that it got echoed back by the server, but this is a reflected XSS attack, which it isn't. It just was there originally. And it will block it. It will remove it. So let's just do that. And it says, yeah, XSS auditor refused to execute the script. And 5, it didn't execute that part of the script. We, as an attacker, just chosen to remove one part of the script from the website, and it never got executed. So yeah, you can do that if the protection is in this mode. And yeah, so therefore don't use this mode. It actually might help the attacker by allowing the attacker to remove a script from your website, and that might lead to some non-trivial and funny bugs. It's not always exploitable, but there were cases in the past that it was exploitable. So do always use this in blocking mode. So this is one thing I wanted to show you. And this isn't, by the way, like limited to Chrome. I'm pretty sure like Edge, Internet Explorer do the same. I'm not sure if, oh no, Firefox I think doesn't have XSS protection. I think, keyword, which isn't a bad thing. Because again, it's like an antivirus approach, a heuristics approach. And these approaches just don't work. By the way, looking from an attacker attacker perspective, you can usually bypass the XSS auditor or any XSS heuristics the same way malware authors bypass antiviruses, is like by mutating the payload a little. And there have been papers published about it. This isn't like zero-day knowledge. This is common knowledge. Okay, cool. So the last thing I wanted to mention and touch base on is basically CSP, which is Content Security Policy, which is a rather new thing, and there are two versions of it. CSP Content Security Policy. Here we go. It's basically a header, and I'm not going to talk too much about it because I talked about it on one of my previous streams when I did the XSS, which wasn't really an XSS, but exfiltrating data when the content security policy prevented an XSS. Just look for my CSP content exfiltration stream if you're interested. But basically, you send this header and and then specify a policy. And the policy can be no inline scripts allowed. That means that anything which is an inline script, this is an inline script, it won't be executed. And this is a good thing. Instead, scripts which are in separate files on the server can be allowed. So if I would do script src and like main.js, this would still get executed because this isn't an inline script. This is actually references and executes a script which is in this file. And usually you don't get reflected XSSs in files which are like separate from the website, which don't actually mix data and code, right? And it would block all the other things which you could normally inject. There are some problems with that because on large websites it doesn't really scale. It's somewhat problematic. Also, like a question would be, if this script actually creates a DOM element, which is a script tag and has some code, which is an inline script, but should it get executed or not? And there's also in the policy you can specify how do you want that behavior to behave. And when you go to like jQuery and other scripts which you probably want to use, then they do all sorts of magic stuff. So yeah, it's hard to get a proper policy to, well, on large websites to still allow all the scripts, your scripts, to execute, but disallow XSSs. But it's still way better than not doing anything, I think, as long as it doesn't give you a false sense of security. And also, it's not related only to scripts, by the way. You can like block images, fonts, well, and some other media as well. And specify like from which websites can it be loaded. So that's one thing, and the new version of CSP actually allows you to not really specify a policy, but specify a magical string, where the magical string, if the announce, it's called announce by the way, if the nonce or nonce, I don't know, nonce, let's say, if the nonce actually is put next to I think it should be here. I should be able to show you. Nonce. How do you spell it? No, seriously, I'm making some. Oh yeah, here we go. Yeah. Basically, the idea is that you specify this magical string. It's supposed to be random, and by random I mean securely random, so it's unguessable. You specify it in the headers, and then you execute only scripts, for example, inline scripts, but also loaded scripts, which have these nonce. And if a script doesn't have it, then you don't execute it. And you can pass it to all the scripts which actually you want to execute, because you know that on server side it's easy for you to pass it to all the scripts on server side, but the attacker has no idea how to guess it, and you randomize it, re-randomize it every loading of a website. So if the attacker can steal it now in this load of the website, it's useless, because they cannot use it now probably, and it's useless for the next load, because the next load will have a different nonce. So yeah, and usually it's supposed to be quite large as well. By the way, one more cool thing is yeah, I guess this, but is there an example here? Let's go to jQuery. Download. CDN. Okay, I wanted to get the CDN, but I wanted to get the CDN with the hash. Yeah, exactly this. Okay, yeah, here we go. If you're loading, well, this is not related to XSS. This is more related to man-in-the-middle attacks on your website. If you're not using HTTPS, or you're using, but something goes wrong. You can, if you're downloading of yours, like from some other servers, a script, you can specify its checksum, basically. And if you specify its checksum, then the browser, when downloads the script, then it checks if whatever is downloaded actually matches this hash. And therefore, if like even somebody switches the script on the fly, or actually hacks into this website and switches the script, they cannot attack you, because you have the proper hash on your website, and they would have to do a hash collision to actually insert something malicious. So this is a cool thing to use. I actually like this feature a lot. Yeah, I think that's actually it from what I wanted to show you about the basics of XSSs. There is, I guess, yeah, it's like a little tip of the iceberg. One thing I wanted to mention is that if you're creating a challenge, an XSS challenge, then you can probably use something called the Phantom.js or some other engines. Phantom.js is a command line scriptable in JavaScript browser, and you can tell it, yeah, when I execute the script, like the script tells it, the browser now enters this website, logs in with these credentials, and then it goes to the URL specified by the attacker, and yeah, and then XSS gets executed. And this is a standard way of actually doing CTF challenges with XSSs. So yeah, know about that, and know that on a CTF, usually you are not dealing with a real browser and a real person clicking on whatever links you send them. You're dealing with one of these in-console browsers, which the behavior might be different there. So yeah, play with it, play with Phantom.js, but keep in mind that the behavior might be a little different. Cool. I think that's it for today. So I'm going to answer the questions there are some questions now, and I guess we'll leave it for today. Are there any mem corruption vulnerabilities in C++ WebAssembly? If it's a good question. If it's C++, then I'm not going to say no, but I don't know what exactly is it compiled to. So I have to look into, but I wouldn't be surprised, in all honesty. But yeah, it depends on what is it compiled to. What about CSRF token? Yes, CSRF token is something which you include in a form or in whatever URL which does a meaningful action. And it's supposed to be random, not known to the attacker, known to the browser of the actual user, and the browser with the request should send the token. And therefore the server side can verify this request came from the client and has the token, therefore the client actually issued it because they knew the magical token. And it's used to prevent XSRF, where XSRF is an attack where a malicious actor tricks the client, the browser, into issuing a request with a given parameters, right? But since the attacker has to know this magical token to include it for the request to be respected by the server side, well, they cannot because it's random and they don't know it. So if you have an XSS, XSS is actually a more powerful attack, which means using an XSS you can actually still steal the XSRF token and still submit the form, or like just send it to the attacker and the attacker can trick the browser and send the token. So yeah, but that's basically about CSRF. Does image recognition destroy reCAPTCHA? I don't know, in all honesty. I didn't look into how secure reCAPTCHA is, so I just have no idea. How should we approach finding XSS during pentests and CTFs, especially when we have lots of subdomains, forms, etc.? It's a good question. Maybe you can try to automate it a little, for example, Phantom.js, right? I mentioned Phantom.js as being used on server side and CTFs, but the same technology can be used as a website scanner with like putting, you know, like injecting whatever is on this website to all the forms and all the parameters it can find. Apart from that, well, manual checks might always be the best. It's actually a good question, a really good question. I'd look on the internet for an answer. Use IPython. Yeah, I always forget to turn it on. Okay. You can also use WebDrivers for automation. Yeah, I think this is one of the things I mentioned. Using Python with Selenium. Yeah, I guess this is, another thing you could use. Did my interface for question just freeze? Let's reboot it. Yeah, I'm not sure about my interface is working. Anyway, yeah, it does. Is that possible to crash the kernel from user mode? Yes, it's possible to crash the kernel from user mode if you have found a bug in the kernel. If you found a bug, then yeah, you can crash it. If there are no bugs, it should not be possible to crash the kernel. If you can't, then that's the bug, basically. Either a denial of service or actually, you know, a privilege escalation, which is just pretending to be a denial of service. What do you think about the fact that in market share statistics, browsers like IE5 or OSs like Windows 95 still have some market share below 0.1%? Isn't that strange? I'm not happy about it from a security perspective, but it is not that strange. I'm pretty sure there are devices on the internet which are like legacy, nobody wants to touch them, and yeah, and there's no way to update them. Like, for example, please remember that like Windows it's known from desktops and laptops, right? But it was also put in some like a super expensive scope for like 50K, and it has Windows installed on it because of reasons. On the scope, yes, on the scope. You heard me right. And nobody's going to update it because like you don't want to break a scope which is worth 50K by installing a needless software update, right? Or like a ATM might have an old version of Windows. I think actually OS/2, or was it OS? Yeah, OS/2 was really popular with ATMs up to the point that it's actually, you can still buy it. It's got renamed, but you can still buy it for ATMs. So it isn't that strange, but it is risky from a security perspective, right? Does CSP apply to recent CSS background image usage for keylogging? I'm sure I should know about that attack. What was it with the background image? Oh, it's probably the same which I showed on a few streams ago. I think CSP applies to it, but I would need to double check. It's like fuzzy in my mind right now, and I'm not an expert in CSP, by the way. So yeah, I'm afraid I cannot answer your question. This is my answer. Any hints about browser plugins? No script? Use the default settings, or should we adjust? I don't know. I use a couple of, ad blockers or weird stuff blockers. I know no script is pretty popular. I'm not sure I have other plugins actually. Yeah, I don't have too many good ideas for browser plugins which you could install to make it safer, to be honest. But current web browsers are pretty cool when it comes to security. So there's one thing which I didn't mention today. It's called an UXSS, a universal XSS. It's actually an XSS which works on all websites due to a browser bug. And this is also something funny, which probably a no script will protect you against in most cases. But yeah, it is a bug in the browser and it needs to be fixed in the browser. And yeah, thankfully these are discovered and fixed pretty quickly, even when there are a lot of people looking at it. So that's cool. But yes, still from time to time something like that emerges in the wild. So please remember that something like XSS, universal XSS, also exists. Cool. So I think that's it for today. Thank you for being here. And next week we're going to, again, I guess, do some basics. We're going to be a stream about serialization, actually deserialization bugs. The standard in Python, PHP, maybe Java. So yeah, I think that's it for today. Unless there's one more question. Why are there still memory corruption vulnerabilities in 2018? Is security industry so bad? The reason is complicated. It's because we like speed, and we like that C++ and C have undefined behavior, and we like writing sloppy code without using the newest feature in C++. And C++ also requires you to do a PhD in programming PhD in C++ before you can program safely in it. So yeah, that's why we still have it. Okay, cool. So thank you, and yeah, see you next week. I would like to again say thank you to KrzaQ for being here, being my moderator, and I also see Foxtrot Charlie is online, so thank you for helping as well. Yeah, I'm going to leave you with some music again. No mission today. Hopefully next week. And I'm going to publish the notes and so on my GitHub. So that's it. Thank you and goodbye. Bye-bye.